Hello and welcome to another Tag1 Team Talk episode, the podcast and blog of Tag1 Consulting. Today we're going to be talking to and walking through some code examples with Fabian Franz, the VP of Software Engineering at Tag1, about how to reduce the complexity of your applications by using Preact and HTM. I'm Michael Meyers, the Managing Director of Tag1 Consulting, and this talk is going to be broken up into two parts. This is part one. We're going to be talking about why application development has gotten so complex. There are many great reasons for it, but it isn't always necessary. And in part two, we're going to be talking specifically about reducing complexity and making your development a little easier with Preact and HTM. Fabian, welcome. Love having you. Appreciate you giving us a walkthrough today.
Yeah, glad to be back.
So, let's start with the broad overview. Why has development gotten so complex? What are you referring to when you say that? Can you give me some examples of how it's gotten complicated?
So one thing that I've seen many people add to things is tooling. And don't get me wrong, tooling is great. We have things for managing dependencies like Composer. We have things for managing dependencies in JavaScript world like npm or yarn. But as you can see, there's already two managers for that. So maybe it's a little bit complex tooling. And then when you build a JavaScript application, especially in the front-end world, then you have to deal with Webpack and or other technologies, bundlers, previews, Yarn Watch. Like, for example, you want to just do things, change some things, and then you have to always have a watch process running that is persistently checking your files and checking if there's any updates, and it rebuilds the JavaScript application. If you talk about the front-end world more in terms of CSS, and there have been Sass, LAS, SMAX, etc. And all of those, you will also have a process running persistently that is watching all the time, has anything changed, and then it rebuilds the things. Often, as a nice side effect, also shows you a live preview, like your app is nicely hot reloading, changing. So there's advantages to that as well. But all of that tooling led to the, on Twitter I've seen that there was someone was like, yeah, for getting into JavaScript nowadays, you need a PhD. And this was one of the parts. On the PHP world, on the other hand, for example, some examples are Composer, where you're building, you are not having your application like traditionally. You have your PHP application, you add your modules, you push it to a server, and then it's deployed. But besides that, you add an additional build step. So another build step, like you have a CI/CD system which installs everything from Composer, then it builds your application essentially, and then it deploys it to the server. Maybe also builds your CSS, maybe builds your JavaScript at the same time, etc. like that. And for me, that was a surprise. I know these trends are there, but I personally don't really like them as much. And the reason is that I come originally from a C++ background. I've been a professional C++ programmer, long-term open source contributors to various things, from Linux kernel modules over patches, over just hacking things a little bit there, over various open source projects written in C. And you know what? In the C world, and also Windows programs and etc., you always have this thing called the build. To the extent that Joel on Software once said, if you have like a nice program, you need to have a one-step build. So you need to be able to deploy your application always just with one step. If you need more steps, if there's more complexity, then what do you do at night? Suddenly, if you need to deploy a hotfix for some application or whatever, if you cannot build it before reading 20 pages of documentation. So like that. And while for a compiled application, a build step is absolutely necessary, we cannot not have it for very obvious reasons, I never understood why people are adding all this complexity to something which is essentially a zero-step build. And also one of the largest strengths of Drupal. You have a Drupal site on the internet, you click on modules, you enable a module, and it's enabled. There's nothing like rebuilding your site because there's a new module now. Drupal all does it dynamically. There might be something happening under the hood, that's fine. but there's no additional step for you to do. So that's what I call simplicity. And again, the simplicity of the first PHP, JavaScript, CSS pages has been you write some little PHP, you upload it to some server, you reload your page, and it's there. You change something, reload your page, your change is there. And same as JavaScript. You change something, your change is there. Same as CSS. So we had a time where we didn't need all this tooling. We had been perfectly fine. And as I said, this tooling adds a lot of complexity. And this is something that I think we can do better. Because complexity introduces people need to learn new things, and they can obviously learn, but onboarding can get sometimes a little bit slower. And what if your tooling has a bug? What if npm is down? What if the composer libraries you're depending on for your build are down? Then you might have a real problem. And that's why we, at least for some clients at Tag1, have developed a philosophy in combination with the client also wanting this of no build step. And that's why I want to talk a little bit more today, but you probably have some more questions.
I have a lot of questions. Before we get into the simplicity side of things, you mentioned, hot previews, what led to this complexity? Was it, just people getting, out of control, or, there's clear reasons why people are using these tools? Is it things like it's adding performance and scalability? What are the benefits of this tooling?
So we have to distinguish several cases here of what tooling we talk about. For example, if we talk about SAS or LAS, which are CSS preprocessors, then it's pretty clear that just by using SAS or LAS as a preprocessor, you need this build step, because you write your SAS, like, for example, if you have some very complex selector chains, and then you can just nest it. But CSS is getting a lot of that natively. So that's the other part. I think historically, many of those tools have not only been written because people just love writing tooling. Everyone wants to write a package manager in their lifetime. But because there was a necessity for it. Because if you go back 10 years or 5 years, the browser world wasn't there where CSS could do a lot of what it can do now. There were no CSS variables. Not at all. Or at least there were, but then there was Internet Explorer 11, which is now finally deprecated, which you still had to support, or it was supported in Chrome, but it was not supported on Safari on some obscure older version, or it was supported in Safari perfectly, but then Firefox had a bug so that you couldn't use this new functionality all the time, because then you would break Firefox, etc. like that. So web developers, especially in the front-end world, have had a pretty rough time, I would say, over the last years. And we are in what I would call a golden age by now, where browsers, and that's what we will be using later in the next part, browsers are now having JavaScript modules, which allow a lot of that, what I'll be showing. CSS has become so powerful with the CSS variables and certain other things that have been added to the spec, like Flexbox. Imagine we used to style with floats and sometimes even back to tables if the layout was too complex. And in the very old days of Netscape 2.0, we styled everything with tables. So I'm just saying there's new things like Flexbox, CSS grid, CSS variables that just make things a joy. But before, you had to use SAS or LAS if you wanted things like CSS variables, or you need to write very disciplined handwritten CSS code, which is a lot of what we had done then in the end. It works, and for not too complex layouts, it's still a great choice to use vanilla CSS, even when the web wasn't as great as it's now. But SAS and LAS obviously also have the advantages. I'm just saying, as we are approaching, in my opinion, a golden age, those tooling becomes less necessary in that, or at least this explicit build step in that.
Before we dive into some of your explicit solutions, which we're going to do in the next part, just conceptually, how are you suggesting that we reduce this complexity? And is that a parallel to, are you saying harkening back to the old days? Like, we're not doing things in tables, but what is your general approach to getting rid of these build steps and, these tools that aren't really necessary anymore? What are you advocating for?
Yeah, on some of the sites I've been working for over 7 years now, and how we avoided these build steps is we never allowed those tools in the first place. So another point is if you're writing a headless JavaScript application, for example, or a real application like a front end, like something which is tracking times or tracking to-dos or something like that, and everything is JavaScript based, you definitely want some tooling for that. That's for sure. It's just for our more traditional Drupal-based websites that I'm saying, and you sprinkle React widgets here and there, or some JavaScript, some interactivity that you need, that I'm not really seeing why we need all this complexity in that. And you are right. For example, a build step can reduce, for example, the size of the JavaScript that's served, like it can be minified, it can be optimized in that. However, Drupal is still, unless you deactivate it, but as soon as you use certain functionality, Drupal is still using jQuery, which is like 200 kilobytes and 40 kilobytes gzipped, I think, roundabout like that. So even just by using a framework like if you use Drupal 7, then you surely have jQuery. Even just by using that, you had so much more bytes go over the wire, essentially, that now optimizing your little custom CSS that has been added to the Drupal site is not a huge win in that. So modern JavaScript, for example, can be tree-shaked. That means only those parts that are actually used by the system will be compiled in your bundle. That's all great. But here we come back to performance optimization. Performance optimization is a step that comes afterwards, not the step that comes before. And why should I, as a developer that develops locally, need to optimize my site for production performance? Unless I want to test production performance. No, usually that's not needed. JavaScript is much, much, much fast enough. V8 has become so fast. All those JavaScript interpreters are blazingly fast. It's just not needed. So my approach to performance always is, unless you want to test something specifically, that you optimize when needed, essentially. And this is an optional step. Functionality first, and with performance in mind, obviously, but then the optimization. So if I ever have the problem that one of my sites that is using a non-build approach is getting much slower on production, and I need the speed or the win of all that, it's very easy to add tooling, to add this build process just for production, even do it while on live. Drupal was great in the old days in essentially serving uncompressed CSS if it's there, but if there's minified version available, serve it as well. So you could even do it on the fly, like in some cron process, background, etc. You wouldn't even need to do it at build time because it's an optional step that is making things better, not different.
That's a really important, I think, concept and distinction. There are applications that require tooling. There are times you need to bring in tooling. These also aren't mutually exclusive concepts. You can do, really simple things in addition to, having tooling. You can mix and match these concepts throughout your application. I'm eager to get into a demo and see how this works. The background was great. Folks, please join us for part 2 coming up in a minute here, where we're going to talk about, reducing this complexity specifically with P-React and HTM. Fabian's going to walk you through some examples using the Umami default Drupal install. Please remember to upvote, subscribe, and share this video out. You can check out our past Tag1 Team Talks at tag1.com/TTT. That's 3 T's for Tag1 Team Talk. We always love your input, ideas, suggestions. You can email us at ttt@tag1.com. Fabian, thank you so much for the background. Looking forward to jumping into the examples, and to everyone who tuned in, thank you for joining us.